Welcome to MMT Chats. This episode is brought to you by ISCAR with new ideas for machining intelligently. Hey MMT followers, I'm Christina Fuges with MoldMaking Technology, and my guest for today's MMT Chat interview is Michael Shone with the University of Massachusetts Lowell Plastics Engineering Department. Michael is one of MoldMaking Technology's 30 under 30 honorees. So first, I guess we should say welcome and congratulations, Michael.
Thank you so much, Christina.
So I
It's a
guess we have to
pleasure to be
start
here.
off. Yeah, we have to start off by asking, how does it feel to not just being nominated, because we got a lot of nominations, but you were selected as one of the 30 we're going to feature in our feature story. So how does it feel?
It feels amazing. I do a lot of work in our plastics department as a teaching assistant, and it's one of those things where it's like students appreciate my time and effort and everything, and it's just so nice to realize like other people think like I'm making a difference with these students.
I love it.
And it's just so uplifting to me, like my hard work is appreciated, and it means a lot to me.
That's awesome. And we're glad that we can be a part of bringing that to many of you. So you said you're a teaching assistant, right?
Correct.
So can you give those watching a little snapshot of, I want to kind of explain how you got to where you are. Like, what was your childhood exposure or grade school, whatever, high school, to manufacturing, to education, and how you ended up at Umass Lowell?
Yeah, so I probably started getting interested in engineering probably back in high school. Um, my high school was a semi-private school in New Hampshire called Binghamton Academy, and
Okay.
they have kind of like some boat classes as well as some engineering-based things. So I was able to get exposed to like a bunch of different trades. So I did wood shop. So I started working with my hands, working on lathes, working on table saws, doing joinery and stuff like that. And then my junior year, I started getting into more of the engineering, started doing some CAD work, and really fell in love with engineering as a whole. And then my uncles on my dad's side was a plastic engineer, told me about
Mm.
UMass Lowell, did a tour, applied, got accepted, and then I've actually been here since 2010. I've done my
Wow.
undergrad, I've done my master's, and now I'm doing my PhD here. And then
Wow.
part of being a PhD, we can be a teaching assistant to kind of subsidize some of our tuition uh,
Okay.
and get a stipend based off of that and get paid for that work. And because of my love for machining from high school and everything, the junior level course is a mold design class where we basically walk a team of students through designing a plastic part, how to guarantee that we can actually fill it with plastic pressure in the injection molding world, and then actually machining it and then making actual parts. So the class needs a TA just because of the amount of work is too much for one professor. And I basically have been doing it now for the past 5, 6 years
Wow.
in different levels of capacity based off of my expertise and learning on the job with students. So
That's incredible. That's quite a commitment. So I have to ask, so in all that journey, all that time, what has been the number one challenge?
um, probably I joke with students all the time that like every semester is really just like 9 different like design challenges
Right.
that like we go through as a class. Some students have like really um, uh, try to bite off more than they can chew when
Yeah.
it comes to mold design, and a lot of them too, don't have the working with their hands kind of background. So trying to
Mm,
overcome that hurdle of like, I like your idea, we can't really make it because of our limitations. And then some of them, it's like we can do some funky stuff. Like we try to stick to just doing like 2 inserts that are 5x7, and then
okay.
trying to make it out of that material. Sometimes, some designs are just cool enough that like we will make sub inserts that go into that insert to make sharper corners, to make because we only do 3-axis milling, like we run into the issue of
Okay.
like
Yeah.
the tool's just simply not long enough to reach down where you
Got
want
it.
because of your geometry. So we'll make sub inserts so we can get around that tool limitation. and just kind of working around with them and getting them that hands-on experience of running we have a VF4 Haas. We
Okay.
also have a Bridgeport, and I forget what our lathe is, but like we'll machine any sub inserts that we need to go on that, either by hand or on the lathe, or just cut more aluminum on the Haas for them. So it's one of those things of
So it's more or less the technology that you're equipped with can sometimes limit the projects that you can take on to teach the class, right?
correct.
Yeah. Well, what's interesting about that is in the world of manufacturing, that's kind of something they're going to have to learn to a degree, right? You're going to have to workarounds, figure it out with what you have, right?
Yeah,
If you're not going to have the latest, most expensive, most up-to-date piece of equipment or software, figure it out. So I think
yeah.
that's kind of a good skill to have. I also think it's interesting, and I think you kind of said this in a way, going down like the academia road or for a career path, whether it's inside manufacturing or not, or like the trade, right? Like you're in the trade in the way of academia, which is interesting. But a lot of people think like if you're working with your hands, you're not using this. And it's the complete opposite. I
Oh,
mean, you truly
absolutely.
need this to be able to work with your hands. And I think that's the big problem with manufacturing jobs forever, right? Is people think
Hmm.
it's only for a certain type of person. And that is not the case. There's so many opportunities. And that's why this program, this 30 under 30, is pretty invigorating because each one of you I'm talking to is proving that out because you all have vast backgrounds and are coming
Hmm.
into it with different levels of even exposure to making things so that it's going to show people you just pretty much the basic thing is you have to have work ethic. You have to want to show up and
Yeah,
work and learn. That's pretty much what you need to make it. Yeah. And that's really any industry. So,
yeah. And you need to not be afraid to make mistakes too. Like
yes.
I feel like dealing with academia, every student is, aiming for that 4.0. Like they don't want to make mistakes. They want to get it right the first time. And it's like, that's not how this works. We're
Yeah.
gonna break end mills. We're gonna break tools. We're gonna have to remachine things. Like it's okay. Like we're not grading off of were you perfect? We're grading off can you make a part?
Yeah,
Like can you
exactly.
prove that you have a design, prove that it would fill, and then filled it with plastic in an actual press? Like
Yep.
that's what we're aiming for. It's the experience behind did you learn a thing and were you able to produce a thing?
Got
Not
it.
necessarily like this was 100% perfect. Like your
Yep.
polishing job was, class A finish. Like we're not worried about that. We're worried about like can you accurately predict the process?
Yep. That's important. So I've been hearing quite a lot, especially, well, maybe the past year and a half, that there's quite a bit of a lack of true mold design and mold building education out there, right? And as this older or seasoned generation starts to retire, move out, there's all this tribal knowledge, and it looks like a lot of universities, colleges, schools, whatever you want to call them, aren't picking up that slack. Like a lot of those courses have gone away. So you and Matt Small has a fantastic program, and even what you're saying on the mold design side, and knowing Davide Masato too, like I know what's going on there. But what do you believe is missing, like universally, from the educational system at that college level when it comes to specifically mold design and engineering and mold building?
Our biggest problem is like a lot of academia really just focuses on the theory, and there's just such a disconnect of like I understand how a process should work, like I understand the theory behind it, but until you actually start making something and actually like cutting with steel, do you really get a true appreciation for that?
Hmm.
So a lot of our students like will walk in after using Mastercam to make their tooling pads, and like they'll get an idea of like what it's going to do, but like until the Haas is actually running where it's spinning at 15,000 RPM, it's feeding at 25 inches a minute, like and really screaming as fast as like we can push our machine, it the light bulb clicks in their brain
Hmm.
where it's just like, oh, this is not nearly as fast as I thought it was. Like
That's
making a
funny.
5x7 insert takes 10 hours. Like it is what it is.
Yeah.
And I just feel like a lot of universities and schooling in general just focuses on like the idea of a thing. And really, I think until you actually touch the
Yep.
object, touch the equipment, you really don't have that connection. Um, between the theory and the like practical application of it.
So would you say that is how UMass Lowell is different? Is it does
Yes,
provide that?
our plastics department specifically has always been designed around your running equipment. Like we have processing labs where we do extrusion, injection molding and stuff that I teach in the fall, where mold design is a spring class. And that like we are constantly like, we run labs where we have an idea of like an experiment that we want to run. But sometimes the best labs that we have with students is when a piece of equipment breaks and we actually are just assembling it with the students and be like, this is how we fix a problem.
Wow.
Some of those are the best labs where it's like, we understand the theory behind how injection molding works, but pulling a screw is a whole different experience.
Yeah.
Like,
real world. So when those accidents happen, right? That's the real world. That's priceless, really. Yeah. All right. So let's switch over to, so when you got nominated, that form that was submitted, listed a number of awards and accomplishments for you. But I want to ask you, of all that, and maybe not even what they listed, in your mind, what is your top accomplishment so far in your career?
I would probably say up until now, the TA award. So I got an outstanding TA award when I first started doing a PhD. And I think that was the first time where I've always kind of had the work ethic of like, I will put as much time into students as students want and like as they're eager to. So for me, students who want to spend 6 hours trying to learn more processing, want to run the equipment longer, want to make more parts for mold design, as long as I have the free time, I will work with students. And I really got that from Professor Orath, who was my processing professor here at Umass Lowell. And like, just putting the time into students has always been good. And then seeing the department as a whole, I got unanimously awarded the TA award. So every faculty member was like, he did really good work. He works with students. He's a great TA. And I think that was the first time where it's like,
you're making a difference.
Yeah, making a difference. We have a National Plastic Expo that happens every 3 years in Orlando.
MPE,
that award was given at our alumni dinner. So not only did like I get the award, like all the students who went to MPE were there, all our alumni, all the professors, and like I got a standing ovation. And
that's wonderful.
Like, oh man, I turned so red. I was so embarrassed. I was like, I can't handle this. Like everyone looking at me. I was like, oh no.
That's what you get for being too good, right?
Honestly, like I want to be like stage crew. I just want to be excellent, but I want to like be in the back.
See, oh my gosh, that's when it's the best. When somebody's personality is like that and they are awarded or recognized, I think they're the moments, right? They're the moments where even the people on the other side giving it to you feel your energy because you don't really want that. Makes it better. All right, so I can't not talk about what I noticed on the form too, all this research you're doing. Can you fill us in? I know you presented, I think at Antec and some, was it at MPE too? You presented some findings.
Yeah, so I presented at Antec, and I've also presented at the Mold Flow Summit.
Okay, that's it.
And then I recently presented at their Connect conference, which was just a revamp of the Mold Flow Summit presentation.
Oh, got it. So why don't you?
They hit a broader audience.
Was it a virtual event?
The Connect was, because it was the original plan was to actually go to Germany, but with the current situation, they went virtual. So we pre-recorded the presentation ahead of time. They presented it, and then we had like a live Q&A with people who attended.
Nice. So can you fill us in a little bit on the focus of the research and why, and maybe any key findings that you can share?
So my research focuses on leveraging injection molding technology for kind of a specialty material. So we call it powder injection molding, where we are putting usually inorganics, whether it's metal, ceramics, or some other kind of powder, into a delivery system, which is either wax or polymer based.
Okay.
And then we use the injection molding technology to inject into a cavity. And that gives us what we call a green part.
Mm-hmm.
And then what we can do later is actually through thermal or chemically dissolving whatever plastic or wax that we're using, we can be left with just the net shape of that powder. So a little bit different of material side of, plastics is shear thinning, and like
Yep.
we typically are we like that. We like high shear rates and stuff like that for that reason, to make it easier to fill the cavity. Whereas our stuff, because of how heavily filled and it still being semi-solid, actually,
Mm.
we actually high shear rates are bad for us. So like we're kind of like reverse engineering or reverse
Uh-huh.
filling our cavity, where we try to go a little bit slower, but not so slow that it freezes off. Um, so my research is focused mostly on the rheology of it.
Okay.
And then in the process of understanding the rheology, we are actually making our own mold plates and
Hmm.
test specimens, just to kind of like induce shear in specific ways that we can quantify, and
Okay.
then see if we can see any match the theory behind what we expect our material to
Hmm.
experience as far as shear and degradation, and see if it actually correlates one to one.
Wow. Is that something that eventually this research gets incorporated into your program at some point? Like, what's the point of doing all that in terms of UMass Lowell research?
So for me, it's my dissertation.
Okay.
I have a corporate sponsor that sponsors this work based off of interests that they have. Um, so we probably won't do any powder injection molding, but when it comes to like different types of mold designs,
Yeah.
the knowledge base is still there with students who are around while I'm doing research, because we do have undergraduate research assistants that work with me,
Okay.
just need more hands. So like that knowledge of like not everything is a thermoplastic. Like
Yes.
knowledge continues on as far as like you might have to do some weird things, and like don't be afraid to think out of the box when it's like this isn't really working. It's like, all right, if the expected outcome isn't working, flip it on its head, do the
Yeah.
opposite. Does that work?
Yep.
So, and it's
I
just
like
one
how
of
you
those
say,
things.
I like how you say you might have to do some weird things. That's a good quote.
It's really fascinating because most thermoplastics, your highest pressure is during injection, and then
Yep.
you're pack and holding at lower pressures. Our material, the opposite. We want to
Uh,
inject at low pressures, and then our packing hold pressures are almost twice as high.
got it.
And it's just one of those things where, because of the type of materials, like it's not a thermoplastic. It's modeled as a Hershey Buckley, which is
Hmm.
known as Bingham plastic,
Oh,
where it
okay.
actually has a yield stress. So those higher pressures are to overcome the spike in viscosity that we get as we get slower and slower. As our shear rate approaches zero, we effectively become a solid and infinite
Oh,
viscosity,
wow.
so it doesn't flow anymore. So we need
Ah,
much higher pressures to just pack out a part now, because of how slow we're filling the cavity
yeah.
to
Oh,
pack out that
interesting.
stuff. So, and it's just one of those
Wow.
things where it's like off of the cuff, I would assume like, oh, we just can't make a part, but flip the script on its head, try higher packing pressures, see what
Yeah.
happens. We
See
made a
what
better
happened.
part.
That's so cool. That's what it's all about, right? So, all right, related to that, I'm sure you've been exposed to a lot of technology, whether you've seen it, read about it, used it. Is there a technology in particular that is the most interesting to you so far, and why?
Um, Honestly, just the basics of injection molding. Like, just give me a machine that can make changes on the fly, that can hold tight tolerances. I personally love fully electric machines. I just like the quiet.
Yeah, yeah, exactly.
Like, it's
It's the little things, right?
it's the little things. But like, I just like injection molding as a whole for me is just like the passion. Like, my dissertation is focused on using injection molding machines. It is applying theory to materials to
Hmm.
injection mold.
Okay.
I'm designing molds to be in an injection mold. Our corporate sponsor has actually designed some molds that we have helped, um, based off of our knowledge base, redesign.
Hmm.
The molder that they're using, they're used to thermoplastics, and they make some beautiful thermoplastic molds. And it's like, man, if I was shooting a polypropylene or tips or something, this would be great. But I'm not. Like, we
That's
need
so
to open up
funny.
these floorboards. Like this sharp corner needs to be radius like 10 times to the sun. Like
That's so
this is
funny.
just too much shear, like too much flow. Like I can't. We won't make a part with this mold as is. Like, and it's just fun to go through that design process with people where it's like they don't have the knowledge base like of this specific material that
Yeah.
is cool. Like I just love it.
So you get to see, you've been doing this long enough where you've seen just classes of kids or young adults come
Mhm.
through. So is there a trend in the type of student you're getting that's focusing on this area of manufacturing? Like talk about your students and what you're seeing, certain characteristics or skill level.
Um, so our students, I feel over the years, uh, we really have like a bimodal distribution,
Okay.
where it's like we have all the kids who love working on the computers, like love the theory and like love materials, and like
Okay.
that's where they're strong. And then we have all our processing kids who love the hands-on, love the labs, like are all about getting dirty, getting oil on them, getting coolant on them. And it's really funny, like seeing, because of how large our classes are, like we have group projects. The
Right.
mold design class is a group project of anywhere from 4 to 7 students, depending on the class size that
Okay.
year. And it's really fun watching like those two kids interact, because I feel like the kids that do have the background of I make things, like I have a 3D printer at home, like I model for fun, like I do welding on the side as a hobby. Like I
Hmm.
do woodworking for fun because of
Yep.
my dad and stuff like that. Um, Watching those kids work with like the kids who are like 100% theory, who like are always looking for the equation of like what is the right answer. It's funny to just like watch them work back and forth on like trying to develop a design, but like we always have both of them,
I
and it's
think that
great.
again, I think that's real world, right? You always have
Hmm.
like there's this known the mold builder on the production floor and the mold designer, in the office designing, and they're in some shops there's still that wall there, right? So
Hmm.
seeing that they're experiencing that in the school setting and have to work it out and actually get to know each other's value to the whole process,
Hmm.
right? To the end product. I think that's really really cool that they are
Yeah.
seeing that at that young of a, in their career path. And that kind of brings me to, I was going to talk about, workforce development and mentoring. And that's what that kind of is. They're kind of doing that with each other if they're open to it.
Hmm.
If they're not standing there
Yes.
fighting against, I know it better than you, but if they're working together, they are actually mentoring each other in school.
Yeah. And I think the biggest thing that has always been a problem is just communication. Like it's one of those things where it's like you can be as smart as you want. If you can't convey your ideas to another person, you're not going to get anywhere in the conversation. Like
Yeah.
it is just going to be a stalemate where you're like I know better than you. And it's like, no, but like explain why you think you know better than me,
Yes.
because I can't get on your level unless you can explain it. And
Yep.
I think with this group project, with how much work it is over a course of a single semester, a lot of students are getting that valued information of like working with a group is
Hmm.
hard, like coordination,
Yep.
having everyone be on the same page without like being a micromanager, where you're constantly like looking for updates and stuff.
Yep.
It's one of those, it's a soft skill that I think they learn through the course of doing it. And
Completely.
it's great to see at the end of the semester is like we always ask like what did you what was the best thing you learned in this class, like what is the most value. And half the students all the time are like communication and just
Wow.
how important it is.
Wow. That's good to hear that they're, again, learning that early on. Because that, I mean,
Mm.
everybody knows that no matter what industry or job you're in, I would say, what, 99.9% of the problems are coming from some level of miscommunication. It's the truth.
Yeah.
It is the truth.
Yeah, and communication of ideas, like, you're
Yes.
dealing with people who are trying to pay the bills of like you want a piece of equipment. Why do you want that piece of
Yep.
equipment? And it's like you got to sell your work, you got to sell your ideas.
Yep.
Like you need to be able to communicate them
It's
effectively.
true. So all right, so you're exposed to the next generation constantly and where you're at versus the
Hmm.
other people that I talked to that were in the shop environment. So do you believe, or what do you believe to continue to attract the even younger? What do you think has to change in manufacturing and maybe mold making specifically, or maybe academia focused on plastics and mold making? What do you think has to change to attract more young people to go down this path?
Um, I really think it's just exposure to it. I feel like for me, I only got into plastics engineering because my uncle did plastics engineering.
Okay.
Um, there's only about 4 or 5 schools, I think, across the nation that have an undergrad in plastics of
Yep.
something. Um, and it's just, I didn't know about it. Like, as I was looking for colleges, like, I was looking at mechanical engineering at a whole bunch of different schools prior to hearing from my uncle about plastics engineering. Because he was more on the sales side. So, like,
Okay.
my brain always associated with him, like, oh, he's in sales. Like,
That's funny.
not
Yep.
he's an engineer that does sales. Like,
Got it. Oh, that's so
um,
funny.
so it was one of those things where like UMass Lowell was never on my radar until like late junior year, early senior year of high school, where it's like, oh, maybe I'll like this as an engineering. And doing a tour, like the open houses they're actually running equipment for, and
Yep.
like to see like what you get to play with essentially was just like
Oh, that's a
I
good way
could
to do
get
it.
behind this.
Yes.
Like I this looks fun.
Yep.
Like
And I could
so
get paid for that, right? That could
yeah,
be a
right?
job. You would
So,
think everybody says the same thing. It's exposure. Like it's like this huge marketing problem of a whole
mm,
industry. And knowing we can't really no one's really solved it. Like it's really hard and it seems like we have to get younger and younger. Like people are talking elementary school and middle school, like exposing them, finding the right way to expose them at a young age so they even like you're saying, they even know it's an option. They all have these toys and devices and they drive cars. All that we use all this stuff every day, not even thinking. And I was one of those too. And before I started covering it, like not even thinking, where did this come
yeah,
from? That's how almost selfish we are, right?
yeah.
Where did it even?
It's
I
just
don't
there.
care. It's just there, just for me. So I agree, it's exposure. So let's talk more about you. If you fast forward 5 years, where do you see yourself?
So hopefully still teaching the next generation. So the thing that I'm getting my PhD for is because I want to become a professor. I think I've worked a couple internships and co-ops where there's really a disconnect between like just working with plastics and because of like how prevalent it is in our nature, like there's a lot of problems in the design process where it's like people just don't understand plastics. Like there just needs to be
Hmm.
more focus on plastics engineering as injection molding is just becoming more and more of a of a standard of how we make parts because
Yeah,
we're no longer looking at, oh, we need to make 100,000 parts a year. No, we need to make tens of millions of
yeah,
years a year.
exactly.
Like, and it's one of those things where it's like, how do we do that? It's like injection molding is definitely the way
Yeah.
everything's going.
Yeah, well,
Like,
isn't it funny? I love that you're saying that because that's my world too. But there's also this additive manufacturing that has come, not
mhm,
that it's new, but and I think there's a lot of myths and misconceptions about that technology too, where it creeps into the molding, where people question, is it going to replace, it's the toolless technology, is it going to replace molding? And I'm always like, do you understand the
no,
high volume of parts that we're talking about? I can't, now we could be wrong, but I don't know in our lifetime is that if that I mean, it's advanced a lot in a short amount of time, but come on, like,
there's no way. Like again, it might replace like small numbers of like
yes,
oh we make a couple thousand a year, but like and it might dominate kind of that market, but I don't think it's ever gonna match up with, oh, I have 128 cavities and I make
Yeah,
a part, I make a cycle every 6 seconds, and
exactly. Pumping them out, pumping them
yeah.
out. Do you ever work with, in terms of the additive, 3D printing, in terms inserts, the conformal cooled inserts? Do you do things like that within the program or no?
So we have research that kind of focuses on that. So we have other PhDs. In the past, another for my advisor, predecessor of me in the department, Gabriel Mendable, did a lot of research on like structural stability of inserts and
Okay.
conformal cooling and how long do they last. Like, can you make them out of plastics and sacrifice cycle time but get
Yep.
more parts out of it per insert? And he did a lot of research around that. So students learn about different ways that we can make molds,
Okay.
but we don't actually like run for labs like those kind of specialty
Okay.
molds,
Interesting.
because students are learning for the first time. A lot of our molds are over designed, I would say, where they're
Uh-huh.
really robust. Like you really gotta like hit it with a hammer to break it, kind of thing.
That's
like
funny.
like it's almost dummy proof. So,
That's
and
too
that's
funny.
really just to mitigate, having to buy, check rings for screws and nozzle adapters, and oh,
Exactly.
we're dropping molds on students, God forbid. Like, I remember when the program first started, we have a safety lecture that we are now required to take because when they first started doing hands-on things, like students were burning themselves because, plastic is hot and like
Yep. Things they
working
don't
with
know.
yeah,
Yep.
working with tools is very dangerous. And like just because you look at it and it doesn't look hot, doesn't look sharp, doesn't mean it's not hot and
That's the
not
truth.
sharp.
Yeah, good point. That is true. Learn the hard way with that.
Yeah, so we started having safety lectures. So we talk about, like risk mitigation and stuff like that. Like how do you lift a mold into a press like safely?
Yep.
Like we go slow, like don't be under it. Like
Yep.
things like students like never trust your equipment to like hold the thing. Like always, have like an escape plan essentially, where it's just like if the mold starts to fall off a table, jump. A mold
Yeah.
can't fall on you if you're above it. Like,
Yeah. No, no, you're right. It is those simple, like we laugh, right? But there are those simple things that could save a limb or save a life, or
mhm,
that you don't really think about. So that's great that that's part of this whole course, because it can be a dangerous place. No matter how high tech some of these facilities are, you're working with machinery and tools, plus
and
expensive things
human
too. Yeah.
error.
Yeah. Yeah. All right. So
So,
last but not least, a little sound bite from you. If I asked you to sell mold making as a career to a kid in middle school or high school, what would be your sales pitch?
ooh, that's a tough one. Honestly, you get to work with your hands, you get to work with great people, and you really get to work with some amazing equipment. Um, it's always rewarding, and you always get to see an end product.
Yeah,
I-
that's key.
you can't ask for anything better than seeing an idea and making a thing that made that idea.
Exactly. That's what I said. The part that makes all the parts. It's the most
Yes,
important part because it makes all the parts that we use. All right, we will end on that note, Michael. Thank you so
awesome.
much for your time and congratulations again.
Thank you. It's truly an honor.
That's wonderful. All right. And keep in touch and continue doing what you do, because we need a next generation of teachers also helping our next crop get up to speed. So thank you. And to everyone watching, remember to visit moldmakingtechnology.com for everything mold making related. Stay safe and healthy, and most importantly, stay informed and stay inspired.